Hey guys, this is 4.4b. So this is going to be our second part of that note portion. So we're just going to continue. What I'm basically changing here is you're going to need to factor. So both 4 and 5 require you to factor before you could find your values of discontinuity or your x-intercepts. Okay, so let's look at this. So first off, let's see, how do we factor something that looks like this? So if you remember, if you have x's in both terms, then that means you can take out an x. So we want to say, oh, what is the GCF? What's the greatest common factor? It would be negative 3x. And then what's left is when we just divide. So like over here, I have an example of that. So we just divide and see what we have left. So negative 3 divided by negative 3 would just give us 1. And we had x squared and we took away an x. So we just end up getting x. So 1x or just x. And then we would divide these. Negative 6 divided by negative 3 would give us a plus 2. And when we divide x by x, we have no x's left. So that is that. On the bottom, this is factorable, like doing a puzzle. So what can multiply? So what could multiply to negative 4? Sorry. And could add to the middle term, which is 0. Excuse me. All right. So that would have to be something like 2 and negative 2. So x plus 2 and x minus 2. So as you notice that these two can cancel, so that would give us a whole. Okay, but we can still write down our values of discontinuity. So x cannot be equal to negative 2 or 2. So we come up with that by just looking at these two factors and say what could make the 0 or the bottom 0. Okay. So then we'd want to say, yes, we've got a whole. So we have a whole when x is negative 2. So again, we said that those come, again, what makes the bottom 0. So it would be negative 2. That's always kind of tricky, especially when they're like the same, like 2 and negative 2. So just remember, when we're doing the whole, we're still trying to find what makes it 0, okay? That factor, okay? So if you have the x and you need to find the y, then we need to plug it into our simplified version of our equation. So negative 3x over x minus 2. So y equals negative 3 times negative 2 over negative 2 minus 2. So 6 over negative 4 or negative 3/2. Again, you're welcome to do it as a decimal, negative 1.5. Sometimes that's easier to plot. Okay, so again, that negative 2 gave us the whole. And then what's left has to be our vertical asymptote. Sorry, I probably should have drawn that down here. Okay, so our asymptote would be x equals 2. So you see we have both of those values. Those are, the whole is the negative 2, and then the 2 is the vertical asymptote. So let's see if we can plot those so far. So we'd have vertical asymptote at 2, and then we have a whole at negative 2 and negative 1/2, which would be like right here. All right, horizontal asymptote, again, we compare their degrees. So coming up here, they have the same. This is x to the 1 and x to the 1. So that means we're just going to look at their leading coefficients. So negative 3 over 1, so negative 3. So y equals negative 3. And we could sketch that. So negative 3 would be right there. Okay. X-intercepts, again, you want to look at the simplified function because the whole isn't ever going to give us an x-intercept. So if we look at this, what makes this 0? It would have to be 0. Okay, so x equals 0, 0, 0. So we could plot that. Again, the y-intercept is also 0, 0. So if the x-intercept is 0, 0, then the y has to be 0, 0. But if you're not sure, you could always plug in 0 for x. Negative 3 times 0 over 0 minus 2. You'd get 0 over negative 2, which is just 0. Okay? Domain, negative infinity to negative 2, negative 2 to 2, and then 2 to infinity. So let's see if we can fill in some of the stuff on our table. So at negative 2, it's undefined. That's where our whole is. At 0, it's 0. That's our x-intercept and our y-intercept. At 2, it's undefined. That's our vertical asymptote. So then we have these two other where we're going to plug it in to find its value. So again, we want to maybe use the simplify just because it is less to type in. So negative 3 times negative 4 all over negative 4 minus 2. And see what you get. Again, use your calculator as much as you want to simplify that stuff. So I think you end up getting 12 over negative 6 or negative 2. So we put that there. And we could plot that right now. So negative 4, negative 2, which is right about there. And then we'll do the same for 4. So negative 3 times 4 over 4 minus 2. And we'll get what? Negative 12 over 2, which is negative 6. So we'll plot that for negative 6. Okay, and I think we have enough information to be able to do a sketch of what's happening. So again, we'll connect the dots that we have. And this will continue getting closer and closer to that vertical asymptote. And going to the left, it'd be similarly, it gets closer and closer to that horizontal asymptote. And then similarly in this area too. Okay? Any questions on that? Great. Let's keep going. We have one more example. So this is probably more like what you'll see on your, perhaps on your test. So these two, when we factor, those are kind of like special cases where GCF is all you do, and then the denominator is like the difference of squares. Okay, these are just normal factoring problems. So what could multiply to, this should be a plus. I need to fix that. So it should be a plus 10. So what could multiply to 10 and add to negative 7? So that would be negative 2 and negative 5. And then similarly for the bottom, what could multiply to negative 2 and add to negative 1? So negative 2 and 1. Okay, so we can, just to maybe have a little more space, we would have x minus 2 and x minus 5. On the bottom would be x minus 2 and x plus 1. And if you notice, we can have a whole here. So, but before we cancel those all the way out, let's make sure we write down our values of discontinuity. So x cannot be 2 or negative 1. Again, that's just by looking at the bottom. So once we have that written down, then we're welcome to simplify that fraction or the equation. Okay, so our whole is the 2, and then the negative 1 would be our vertical asymptote. So to find the y for that, we'll plug that in. So we'd get y equals 2 minus 5 over 2 plus 1. Again, we're just taking that 2 and we're plugging it into that and we should end up getting -3/3 or -1. Okay, so let's see what we can fill in on our table. So we know at 2 and -1, it's D and E, or undefined. Either way works, okay. Guess maybe I'll just stay with D and E. D and E, okay, and then we have a hole at 2, -1. So 2, -1 would be like right there. We could draw our vertical asymptote, which was -1. And let's see if we can find our horizontal asymptote. So again, we look at the function. It doesn't matter which one you're looking at. We compare. They both have the same degree. So we just look at their leading coefficients, which would be 1/1, which is just 1. So y equals 1. And we will sketch y equals 1. Okay, so it looks like we already have a lot of information that's going to be helpful. My guess is it's going to be something like this. Oops, that's not going to be helpful. It'll be something like this and something like this. But we want to see if we can find some more points from our table to verify. Okay, so x-intercepts. Again, what makes the top 0? So look at the simplified. It would have to be 5. Okay, so 5, 0. And then the x-intercept, again, we plug in 0 for our equation. So 0 minus 5 over 0 plus 1. So we end up getting -5. So 0, -5. So we can plot those. So 5, 0 would be right here. And 0, -5 would be right here. Okay, domain, -infinity to -1, -1 to 2, and then 2 to infinity. All right, we can fill in some of our tables. So 0, at 0 it's -5. Oops, sorry about that. And then at, I guess we don't have 5, but we could put it here. So 5 is 0. Might be helpful to have that there. And then we have these other 2 points. It looks like we don't have anything in. So we'd probably want to evaluate those, see which we get. So at -5, oh wait, we do, wait. Oh, I think I maybe messed that up. Hang on one sec. Oh, shoot. No, that's right. Okay, sorry, I think on my filled in notes, I think I have something wrong, so be aware of that. Okay, so here we've got at -5, would plug that in, so -5 minus 5 over -5 plus 1, so -10 over -4. Again, you can simplify that to a decimal, 2.5. So we'd plot that, so -5 and then 2.5, which is about right there. And then at -2, so -2 minus 5, and -2 plus 1, so -7 over -1, which is 7. Okay, so now it looks like it looks really good. We'll connect all those dots. Again, they get closer to their asymptotes. That wasn't great, but it's pretty good. Okay, so if you have any questions, please let me know, and we'll see you later.